So before we start, if anyone came here to sit down and just do LeetCode with their headphones on for the next 3 hours, feel free to sit at the back so we don't disturb you. I'm going to be going through some of the questions, interview questions that you can learn from, and I'll teach you what a good technical interview looks like. Right? Because when you walk into a technical interview, you'll be given problems that you don't understand, you've never seen, you don't know how to solve. And I'm going to give you the tools to do that today. So, I think we'll jump right into it. After this, after I'm done my spiel, then we'll head off and then we'll hand it off to you guys. You guys can start doing some practice yourself. So, when you're in an interview and you're given this question, right? This question, listen carefully. Given an input, reverse it. What's the first thing you say?
What's the question again? Wait.
Given an input, reverse it. Yes?
Are we doing it in Python?
Language doesn't matter.
Does Python can just do
Ignore that, ignore that.
or reverse it then?
Before you get to the code, Let's say no library functions, right?
What kind of input is this?
What kind of input, right? Because when you're given an interview question, it's going to be vocal. It's not going to be like in LeetCode where you get every single input, you get every single output, you get samples, you get an idea of what the question is going to be like. In LeetCode, it'll say, given a string of up to 120 characters, reverse it and return a string. That's easy, that's simple. You know exactly what that's going to look like. That's not what an interview is going to give you. And you're going to have to beat it out. So the first thing you do in an interview, when you get a question, is you ask questions. What actually am I supposed to do? So you might ask questions like, what is this input? You know, how many times do I have to do this? What should this look like? What happens in this case? Is this valid? Is that type valid? What do I have to think about? And once you've exhausted your questions and you feel like you understand the problem correctly, then you can start looking at what that problem actually is and solving it. But don't jump to code, because when you jump to code, you don't understand what's going on. You don't figure out the design, you don't figure out what the fastest way to do it is. Because the interview is not just asking you to give a solution. They're asking you to give the best solution. What does that mean? Fastest, doesn't use in-place memory, uses the least memory. A lot of different things can be a best solution. But you have to start from one place and then work towards getting the best solution one step at a time. There may not be a correct answer, but as long as you show the interviewer you know how to work towards that correct solution, that's what gets you the point. So, you want to understand the question intuitively. Now, we can get a comp sci question or a really, really hard logic problem, and we can be like, okay, well, if you like transform it this way or if you do it that way, and then you start jumping into algorithms and stuff, that's a little too far, right? First thing you want to understand is, if I were a person doing this right now, using, let's say cards in front of me or objects in front of me, how would I do it? Would I pick them up and put them in this location? Would I go through the first couple things and then choose those? Would I do some other kind of method? But most importantly, how would I think as a human? Because some of these problems may be easy to solve as a human. As a person, we can be like, oh yeah, I can sort a deck of 52 cards. But implementing that into code is really hard. So first, understand how to do that problem as a person. And then do some sample inputs, outputs. Because again, you may not understand the problem. You may not understand what happens in this case or in that case. The string is already reversed, or if this happens. And once you do that, you should hopefully have a good understanding of the problem, even if you don't have an understanding of the solution. And then you acknowledge the worst case scenario, right? The brute force solution. Now, the brute force solution, for those of you who don't know, is the slowest, awful, most slowest possible solution to any given problem. It takes a lot of time, it takes a lot of memory, it does a lot of extra work that's unnecessary, but it works, right? And that's your first starting point. Now, sometimes you're like, oh, this problem is so easy. I'll just, do a sort and then I'll move it. Start with the brute force solution, and then you can show the interviewer, oh, I know this is slow and I can move towards getting it better. I know I can use this thing to make it better. I know I can use that thing to make it better. I know there's this thing, but there's a trade-off. And now you're showing those analytical skills. You're showing that you can take a hard problem, or maybe that in this case it's an easy problem, but you can approach it like a hard problem. And you can figure out what steps you need to do to get that best solution. And we'll show you an example afterwards, don't worry. And then once you have that brute force solution, let's say it's sort a list. Sort a list of, I don't know, 10 integers or 100 integers, however many. You say, okay, I'm just gonna, do bubble sort. I'm just gonna do the worst naive solution. And that's gonna be n squared time, right? Because that's going to take things, and it's going to move them, and it's going to move things n times for n items. So it's gonna take n squared. That makes sense, right? More complex algorithms might be something like log n, or n to the 3, or worse, 2 to the n, right? But you start out with showing them that you understand basic data, because not everyone does. Also space. Bubble sort, how much space usage does bubble sort have? Anyone? Anyone? No one?
n+1.
N+1. I think so. That sounds right. Yes. If you actually exclude the already in place materials, the already in place storage, it's actually just 1, which is perfect. It doesn't use any space, but it uses a lot of runtime. So you're like, okay, how do I make this runtime faster? And because it's a sort, I'm not going to go through that, but you would use a bunch of different techniques in the logger process. This is when you optimize, you iterate, you go, okay, I'm going to replace this. This thing is duplicated. Maybe at this place, I use a new array and I copy everything, but that's wasting a lot of time, and I can just do it in the same place. I can save time, and I can save space. And you don't understand those things until you write out what it is you're trying to do. You can also use other methods. Binary search is the most common. Splitting a list into 2. It's sorted, 0 to, let's say, 100. You check something in the middle, you're trying to look for, let's say, 30. And this happens to be 40. Okay, it's not that one, so you go here and you check 20. Not there. You're like 32, and you're like right here. Binary search. Hopefully you guys know that. Logarithmic search, you can talk about it in an interview. I don't think any interviewer would expect you to understand it. But logarithmic search means if your scale is from 0 to 100, and then you're looking for, let's say, 5, right? And then you somehow get this middle point and it's 40. Well, 5 is most likely not going to be in the middle. So you do some kind of check to see, can we do it more towards this side? That's a little more complicated. You don't have to worry about implementing it, but know that it exists because it's faster than binary search. Logarithmic search, arrays, lists. I don't need to tell you guys, use your arrays, use your lists, but also try not to use them too much. Linked lists. Linked lists will come up a lot because there's going to be a lot of pointer problems. Or there might be reordering of information that is tough to do without linked lists. Or they'll give you straight up a linked list question and ask you to solve it. You should remember that there are single linked lists, double linked lists, circular linked lists. That's about it. That's mostly about it. But when you get into those scenarios, they're a little bit trickier. So try some problems if you don't feel comfortable. Stacks and queues. Stacks and queues can be really tough because you need to track where things are going. You need to put in different items into the stack or queue, but they can be an incredible solution to something that seems unintuitive without it. And we might have a problem that uses it later. We'll see. Hash maps. Hash maps is your golden key to making things extremely fast. Does anyone know what a hash map is? Yes?
Hash map, basically, you take the input and then you use the input as software key to store it somewhere.
Yes. So it's like building a key value store. Essentially, this is a data structure in almost every language. It's very common. It means that, let's say I want to take, one thing I did in an assignment was actually hash. I wanted to map my name to my email, and then Pranir's name to his email, and then Fiona's name to her email. And that meant that when I wanted to, Ishan's name to his email too. And that meant that when I took that key, and I took the hash map, and I said, I want Jeffrey's email, it would immediately give me Jeffrey's email. But it wouldn't search through n things. Instead, it would use O one time, because it uses this clever little algorithm that sorts things and then gives you things really quickly. So you assign it a value, like putting something in a lockbox, and then you retrieve it almost immediately. This means that you can get and retrieve information in O1 time, and that is crazy fast. It's really useful when you're trying to check a bunch of things and see if there are duplicates. It's really useful if you need to retrieve one thing from a list of items really quickly, multiple times. Right? So make sure you have those down pat, because if you don't understand these, then none of this will be useful to you. Because you'll come up with a brute force problem, and you'll be like, I don't know how to make this faster. I don't quite understand this. But if you understood a stack, then you could understand I can build a stack, I can put things in, and I can take things out. Right? And now you can use this tool, replace your ugly problem with it, and then get a better solution. Yes?
So let's say that there was a question where you wanted to use a hash map.
Yes.
Would you be expected to implement like the hash function for the map?
No. So in most cases, unless they specifically tell you that you have to implement this yourself, you can just assume that it's there. You can just assume that you can call new stack, and it'll give you a stack, and you can just do push pop. Screw the implementation, who cares? You can just pretend you have those library functions usually. So don't be afraid to use them, but to use them you need to know how they work. So now let's go back. We've gotten that brute force solution. Thank you. We've iterated upon it to build a better solution, and better and better. Now when we started off, we looked at the big O runtime. Maybe it's really slow, maybe it takes a lot of space. And once you've iterated and we're like, this is the best scenario I can probably find, then you stop and you go, okay, what's the big O now? Because it better be faster. If it's slower than it was before, you're probably not optimizing, you're making your algorithm worse. Again, there are trade-offs. It's good to be able to say, hey, I could use this option, but it'd be slower. But in the end, you want to get the fastest and least space using algorithm. So you settle at the end and you go, okay, this is my algorithm. I think it works. Try some inputs, try some outputs. Say to the interviewer out loud, this is the big O runtime. This is the space usage. Right? And now you know, after trial and error, and sample inputs and sample outputs, that your algorithm is probably correct, and it's probably the fastest that you can do, which is what the interviewer wants. Right? Try samples, I already said that, but make sure you pass samples through your algorithm. Because if you don't pass samples through your algorithm, you can miss your logic. You can misunderstand your own logic about how things work, especially in a more complicated system with more inputs. And finally, once you've done all that, then you can code. And yeah, I know this sounds like a long process. I know it sounds like, you're beating the crap out of some algorithm to try and make it better, but you know the answer already, you just have to show the interviewer how to get there. It's slow, it's tedious, but that's what the interviewer is looking for, not an answer that you spit out in 1 minute. And when you get to harder problems, you won't be able to spit it out. You have to iterate. So that's when you code, and once you're done, you can test with edge cases. Make sure you have your empty strings, your nulls, your maximum inputs, minimum inputs, all these different states and scenarios covered. And now you know you have an algorithm that is fast, that doesn't use much space, and that's correct. Seems easy, right? How hard could it be? Okay, we'll try a problem. Is it on here?
Yeah.
So, I have not worked through this problem yet. So you guys are going to work through it with me.
I'll read it out. Maybe I should write this.
If you have any questions, please feel free to ask. Put your hands up, yell at me, whatever. That's what I'm here for. I have mentored so far 2 other students into the Big 4 companies, so I expect that all of you get into the Big 4. Every single one. I don't want you to break my record.
No one's gonna ask him the question. You've mentored people into the Big 4, but have you
Ooh, I'm getting there. I'm getting there. Google, if you're listening.
The luck comes to us.
By the way, Google, this is recorded on a Google Pixel.
Please give me a job when you're at Google.
I'm just gonna read it out to you.
Yeah, sure, that's fine.
Given an array nums of n integers, there are elements a, b, c in nums such that a plus b plus c is equal to 0. Find all unique triplets in the array, which gives the sum of 0.
Okay.
So you basically have an array of random n integers, and you need to find sequences. So 3 random numbers that make 0.
Okay. 3 numbers that make 0, but I need to find all possible permutation, or not permutations, combinations, right?
Exactly.
Okay. Okay. Any questions you guys want to ask about the question about this interview question yet? It's okay. It's fine. You guys remember that, right? Because the interviewer is going to just give you the question verbally. Any questions? It was pretty clear since it's in LeetCode. You might ask the question verbally like, array nums of n integers, positive integers, such that. Okay, let's say what are nums, right? So the nums is the array, but you want to figure out what's inside it. Can there be negative numbers? Can there be invalid things? No, let's say it can be negative, 0, or positive.
Yeah, it can be either one.
Yes. And what I need to do is, so I need to find all pairs, or triplets.
Yeah.
What is a triplet? What do I output? Anyone have an answer? Any suggestions?
Couples.
Yes, sir?
Couples.
Sir?
Couples.
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 Tuples, yes, tuples sounds good. A combination of 3, and then we can have a list of those. Right? But each one has to be unique. Does that make sense? Any other questions you guys have? Find all unique triplets in the array.
You mean unique? Does that mean that that if I have a triplet of A, B, C, is it considered unique if you have like B, A, C, they're both the same?
They're both the same. So unique
Okay.
means, so the order does not matter. So it's not a permutation, it's a
It's a combination.
combination.
But that brings up a better question that I have, which is, what if you have a list that's 1, 2, 2, 3? Right? Is the first, like 1, 2, 2, 3. Can I take these as 3? Can I take these as 3?
Yes.
I could.
Yeah.
Okay.
So it's
And I
it's
can
not
also
unique
take these.
numbers, it's unique numbers in the array.
Ah, okay.
So if you
Right.
have repeating numbers in the array, you can
Yes.
use it twice.
Okay, gotcha. And the last thing I would probably ask is, in that case, what is A, B, and C? What am I returning? Positions. I'm not returning values. I could be returning values if I hadn't asked that question. But I'm
Sorry.
returning positions.
You are returning values.
I am returning values.
So
What is this?
So for example, I'll give you.
So wait, would I have 2 of these then?
So for example, let's say the array
Yes.
is -1, right?
Yes.
-1, 0, 1, 2, -1, and 4. So you have 2 -1s, right?
Okay, yes.
So a sample solution would be a tuple. We said, yeah. So it would be a tuple where you would have one sample solution is -1, 0, 1. Because that equals 0. Another solution is -1, -1, 2.
But can you have -1, 0, 1 twice because it's using a different -1?
Yes. So in this case, you can.
No, I'm talking about.
Wait,
the
wait,
first-
so in that case, could you have 0, 1, -1, because using this one instead of that one?
Oh, I see what you're saying. Okay, so this would be the same as using
Okay.
either one.
Oh, okay.
But if you use 2, you
So you can use 2.
You can use 2
Okay.
if the number exists.
Interesting.
Good questions.
So I'm returning, huh.
This is a hard question.
So, you know, if I was returning positions, one thing I would have trouble doing is sorting. Because I know I have a list, I know I have things that have, what's the name? I can compare these items.
Well, not necessarily.
Yes.
You could sort the values first and then do all the rest of it with their new positions after sorting it. And then you'd have less of a problem because the negative ones would be right next to each other.
Yes, that is an option. But now I would have to keep in mind that I can no longer, so if I can sort and positions don't matter as much because I'm returning values, that's easier. If I am returning positions, I can't really sort because then I mess up the positions. Does that make sense? I can't go back and track them. So that might be a limitation that, you know, you have to find out yourself.
One thing to realize is these two are the same, right? Regardless.
Yes, okay.
So these two are the same. The only time you'll be using two of the same numbers is if that exists in the array.
Okay.
So, because
Gotcha.
so
You
if
can't
it was
duplicate a number.
Yeah, if all three numbers were different,
Yes.
you can't duplicate that with
Yes.
another thing that exists. If there were duplicates.
Any other questions? I think we got everything. What's up?
Can we have another array that records their position over time so that we can sort it?
You probably could. In my opinion, I wouldn't resort to that unless I felt the other option was too unwieldy, because that does feel unwieldy. Right now, you got to track positions, and pointers suck. Pointers really suck.
I mean, we just have a mirror array with the same stuff, but instead of with numbers, we have indexes on it.
That's true. I could. I could. That is one option. One thing the interviewer might say is, can you do it without this array, without using extra space? But yes, that is an option in that case if you wanted the position. I think that's about everything. Okay, so now you want to understand it intuitively. I think we've already done that. Pretty simple problem here. The solution may not be so simple. So inputs, outputs, we've already tried some inputs, outputs, so I'm going to skip those. Right? You guys understand what's going in, what's going in, right? Yes? Brute force solution. What is the brute force solution to this? I can think of it off the top of my mind. Yes?
You just like start from the beginning and then add them up, and then if they're greater than 0, then up to value 1, and then keep going. And then that way you can get,
That gets some of them, but that's only consecutive, right?
yeah.
Right. That works, but it's only consecutive, so it's not the entire answer. How would you brute force the entire answer? Yes?
Have 3 nested loops and iterate through the list.
Yes.
In queue time.
So what am I generating?
You're generating like a list of tuples based off of like each one of your loops would pick out an A, a B, and a C. Right?
Yes. Yes.
But then that will generate same answers in different order. So like you have to check if you had that answer before.
Yes. So we get that brute force answer, and it works. Let me illustrate the brute force answer. You have an array of -1,